In this video, we're going to continue graphing parabolas, and in particular, graphs are in the form f of x equals x squared plus k. So the k value of this equation is going to be what shifts the graph up and down. Okay, so the vertex will always be at 0, k, because when I plug in 0, the x squared goes away, and I'm left with k. So that's going to be the y intercept here. So when I go to graph this, I know my vertex is going to be at 0, 1. So I go up 1 on the y-axis, and there's my vertex. Then from there, I can find some more values. So I'm going to use my table again, and I'm going to pick 1. If I plug in 1 for x squared, 1 times 1 is 1, plus 1 more would be 2. So over 1 up 2. And I know it's going to be symmetrical, so I can also go back 1 up 2 as well. Let's find another point. Let's plug in 2, see what happens. 2 squared is 4. 4 plus 1 would be 5. So I'm going to go over 2, up 1, 2, 3, 4, 5. And it's going to be symmetrical, so I can go back 2 and up 5 as well. And there's going to be my graph. Notice we didn't have a k value, or k was 1 exactly. So it's positive, sorry, an a value. A was positive, so it's facing upward. It's positive 1. So a shortcut to graph is actually that it's going to follow a 1, 3, 5 kind of pattern if a equals 1. So if a equals 1, it follows this 1, 3, 5 pattern. And what's going to happen is you're going to go right or left 1 unit at a time, and then you're going to go up or down, depending on if it's positive or negative, the 1, 3, 5. So you can see here from the vertex, I move over 1 unit, or right 1 unit, and then up 1 unit. So over 1, up 1. From that point, I would move over 1 unit to the right, and then up 1, 2, 3. I can do the same thing going the other one. Back or left 1, up 1. Left 1, up 1, 2, 3. The next value would be over 1, up 5 from that previous value. Over 1, up 5. And that will always work if a is 1. So it's kind of a shortcut, but when in doubt, just go back to our table to find our values. Why don't you try this example here on the right? Alright, we're looking at this graph. G of x equals x squared minus 2. So first of all, our vertex will be at 0, negative 2, right? So I go down 2 on the y-axis. Then from there, I can make a table and pick some more values. So if I picked 1, I would plug in 1 for x. 1 times 1 is 1, minus 2 would be negative 1. So I go over 1 and down 1. And it's going to be symmetrical, so I could also go back 1, down 1. And then, same thing, keep going. I'm going to pick 2. 2 squared is 4. 4 minus 2 is 2. So over 2, up 1, 2. And it's going to be symmetrical, so I could also go back 2 and up 2. It's always going to be a mirror image across what we call the axis of symmetry. So with all these graphs we've done so far, the axis of symmetry has been the line x equals 0. So you can see that the mirror images are happening right here on the y-axis And the equation of that line on the y-axis is x equals 0, right? So over here, x equals 1, x equals -1. In the middle, this is x equals 0, this vertical line here. So that's the axis of symmetry for everything that we've done so far. So these graphs, mirror image is right there on the y-axis, and the equation of that line is x equals 0. I know that's confusing. It's the y-axis, but it's a vertical line, so it has to be in the form x equals. Alright, in the next videos we'll be talking about what that h value does to our function.